Now that we understand what a square root is, we're going to take things a little deeper with some rules about square roots. And our first rule is going to be about multiplication. And this multiplication rule says if we have two numbers, a and b, then the square root of a times b equals the square root of a times the square root of b. So let's see an example. We know that the square root of 16 equals 4. Well, another way to write 16 would be 4 times 4. So let's look at the square root of 4 times 4. Our multiplication rule says that this equals the square root of 4 times the square root of 4, which equals 2 times 2, which equals 4. And that's what we wanted. We know the square root of 16 equals 4, and using the multiplication rule, we showed it in a different way. And there's one more rule that's important to know. That is the division rule. And that says if we have two numbers, a and b, the square root of a divided by b equals the square root of a divided by the square root of b. So these are the two rules that we're going to focus on in this video, and right now I'm just telling you that they're true. If you're interested, at the end of this video, I'm going to prove to you that both of these are true. So let's look at an example now with the division rule. We know that the square root of 9 equals 3. And 9 we can rewrite as 27 over 3. 27 divided by 3 gives us 9. And the important thing is now we have a fraction. Our division rule deals with fractions. We have a number divided by a number. So our division rule says this equals the square root of 27 divided by the square root of 3. Let's try to simplify this. So 27 we can rewrite as 9 times 3. And using our multiplication rule, the square root of 9 times 3 equals the square root of 9 times the square root of 3. So now we have a perfect square there. 9 is a perfect square, so the square root of 9 would be 3. But what is this? What is the square root of 3? This brings us to a new term. 3 is a non-perfect square. Or we could also call it an imperfect square. So this is the opposite of a perfect square. This cannot be expressed as plus or minus heart squared, where again our heart inside is a whole number. We cannot rewrite 3 as plus or minus heart squared. 9 we can do that. 9 is plus or minus 3 squared. And what this means is the square root of a non-perfect square will be a decimal number. So we've seen that the square root of 1 equals 1, and the square root of 4 equals 2. 1 and 4 are both perfect squares, so the square root is a whole number. With a non-perfect square, like 3, if you type the square root of 3 in your calculator, you'll get a decimal that's approximately 1.73. And it kind of makes sense that our 1.3 is between 1 and 2. If you ask what squared equals 3, that's the same as writing x squared equals 3. And we know that 1 squared equals 1, so that's too small. And 2 squared gets us to 4. That's too big. So if we want something squared to equal 3, that something, our number in disguise, has to be between 1 and 2. And we have to use a calculator, in this case, to get to our 1.73. So let's finish our example above. We have the square root of 9 times the square root of 3 divided by the square root of 3. So since 9 is a perfect square, we know that the square root of 9 is 3. And we have the square root of 3 divided by the square root of 3. So since we have a square root of 3 on top and bottom, we can cancel those out. And we're left with a 3. And again, that's what we wanted. We were looking for a 3 because we know that the square root of 9 equals 3, and we wanted to show this using the division property. We rewrote 9 as 27 over 3, and we used the property to get us to 3 at the end. Let's try a couple more examples using our multiplication and division rules. We want to simplify the square root of 24. So how do we simplify a square root? What we do is factor and find all of the perfect squares. So 24 we can factor as 2 times 12, and we can factor this further. 12 is 2 times 6, so we can write this as 2 times 2 times 6. And if you notice, we have a whole number squared, which means we have a perfect square here. So this is equal to 4 times 6. And since 6 factors to 2 times 3, we don't have any more perfect squares. So we can rewrite our original problem as the square root of 4 times 6. And using the multiplication rule, we can rewrite this as the square root of 4 times the square root of 6. The square root of 4 is 2, so our final answer is 2 times the square root of 6. So our goal at the beginning was to factor 24 and find all of the perfect squares. We found that the only perfect square was 4, so we rewrote 24 as 4 times 6. And the multiplication rule allowed us to split up the perfect squares from the non-perfect squares. And that's really what we're going for. Since the square root of a perfect square simplifies to a whole number, there's no point leaving it in the square root. So we're essentially trying to remove all of the perfect squares from under the square root. So all that we have left under the square root is a non-perfect square. And that's what it means to be a simplified square root. We only have non-perfect squares left on the inside. And another thing to note with this problem is that if we knew that 24 was equal to 4 times 6, we wouldn't have to factor step by step. So knowing your multiplication tables comes in really handy. We have the square root of 18 divided by 5. We want to simplify this square root, and as you might guess, the first step is to use the division rule. So the square root of 18 divided by 5 is equal to the square root of 18 divided by the square root of 5. Now we have two square roots to deal with. And remember, we want to factor and find the perfect squares. So let's look at 18. 18 we can rewrite as 2 times 9. And on the bottom, we have the square root of 5. 5 is a non-perfect square, so we can just leave it as is. All right, looking again at the top of the fraction, we can use the multiplication rule to separate the square root of 2 times 9 into the square root of 2 times the square root of 9. And again, we'll have our square root of 5 on the bottom. So we have the square root of 2 times, and the square root of 9 is 3. And instead of having the square root of 2 times 3, we usually put the whole number in front just to condense it. So we'll write it as 3 times the square root of 2. So all of our square roots are now simplified. All that's left under each of those square roots is a non-perfect square. And just to review, we started off this problem using the division rule. Then we factored to find all of our perfect squares. Our only perfect square was 9. Then we used the multiplication rule to essentially take our perfect squares out of the square root. Then all we had to do was tidy it up to get to our final answer. And there's nothing wrong with how it looks right now. However, for some reason, the fancy math folks, they don't like having square roots on the bottom. And we have a square root of 5 down there. So we're going to use a little technique to rewrite this so there are no square roots on the bottom. So since we have square root of 5, we'll multiply the top and bottom by the square root of 5. The square root of 5 divided by the square root of 5 is just 1. So we're not changing the problem, we're just using a little technique to get to our goal. Rewriting this, we have 3 times the square root of 2 times the square root of 5 divided by the square root of 5 times the square root of 5. On the top, you'll notice we have 2 square roots, so we can use the multiplication rule to combine them, leaving us with 3 times the square root of 2 times 5. And on the bottom, we have the square root of 5 times the square root of 5. And that would just be 5. So the square root of a number times the square root of a number gets us back to that number. And in our final step, we have 3 times the square root of 2 times 5, which is 10, divided by 5. And this is what the fancy math folks like. They like our final answer to have no square roots on the bottom. Again, there's nothing wrong with how we wrote it originally. However, our final answer here, with square roots only on the top, that is the common form. Alright, now that we've gotten some practice with the multiplication and division rules, I'm going to take some time to prove them to you. So far, we've just been accepting them as fact, and they seem like pretty reasonable rules, but we don't know if they're true for sure. I think this next part of the video will be really interesting, so let's get started. So I'll start off with the multiplication rule. So we want to prove that the square root of a times b equals the square root of a times the square root of b. So to start off, I'm going to let smiley face equal the square root of a and heart equal the square root of b. So I just created two variables, smiley face and heart, and then I set them equal to square root of a and square root of b. If you notice, we have a system of equations. We have a team of equations. So if smiley face equals the square root of a, that means that smiley face squared equals a. Just using our understanding of what a square root is. And on our second equation, if heart equals the square root of b, that means that heart squared equals b. Now we're going to combine these two equations. If you recall, in our system of equations video, where we combined the equations, we added the left sides and added the right sides, because we have the same thing on the left side as we do on the right. Using that same logic, we could do more than just add. We could subtract, or multiply, or divide. So in this case, we'll multiply the pieces on the left and multiply the pieces on the right, and set them equal to each other. So we have smiley face squared times heart squared is equal to a times b. I encourage you to review the system of equations video where we combine equations just to review this idea. But since smiley face squared is equal to a and heart squared is equal to b, we essentially have a times b is equal to a times b. All right, let's keep going. We're going to rewrite this as smiley face times smiley face times heart equals A times B. We'll rewrite this again. We can multiply numbers in any order, so we're going to write this as smiley face times heart times smiley face times heart. And that's equal to A times B. Well, if you notice, smiley face times heart times heart is smiley face times heart squared. And that's equal to A times B, or we can just write it as AB. So again, thinking about our square roots, if smiley face times heart squared equals AB, that means that smiley face times heart is equal to the square root of AB. Again, just using our understanding of a square root. And now we have just smiley face and heart on the left side. And again, we said our smiley face and heart are equal to square root of A and square root of B. So let's go ahead and substitute that in. So we have the square root of A times the square root of B equals the square root of AB. And that's our multiplication rule. That is exactly what we wanted. I encourage you to review this proof here and make sure you understand each step. It might seem a little bit like magic, but it's math. And the further along in math you go, you'll learn some neat things like this. We're going to use the same method to prove the division rule. So we want to prove that the square root of A over B equals the square root of A divided by the square root of B. Again, we're going to let our smiley face equal the square root of A and our heart equal the square root of B. So we have a system of equations, and our first step is going to be the same. Smiley face equals the square root of A. That means smiley face squared equals A. And heart equals the square root of B. So heart squared equals B. So this is where the proof changes. When we were proving the multiplication rule, we multiplied the pieces on the left side and the right side. Well, this time we're going to divide. Smiley face squared divided by heart squared equals A over B. We can rewrite the left side as smiley face times smiley face divided by heart times heart. And we can rewrite the left side again as smiley face over heart times smiley face over heart. Smiley face over heart times smiley face over heart is smiley face over heart squared. And if smiley face over heart squared equals A over B, that means smiley face over heart equals the square root of A over B. And now we just have our smiley face and heart on the left side. Remember at the beginning, we said our smiley face and heart are equal to square root of A and square root of B. So we can substitute that in. So we have the square root of A divided by the square root of B is equal to the square root of A over B. And that's our division rule. Great job if you made it to the end of this video. This is the kind of thing that fancy math folks spend all day doing, proving all kinds of weird ideas. I hope that this stretched your mind a little bit and that you found it kind of neat.